So we're starting off the summary of different causes, and today I'm going to be talking about the overwhelming importance of the far future. Next slide.
I thought you were doing the slides.
You want me to do it? I can do it.
Alright, sure. Alright, so I thought a good way to start would be by talking about people who saved the world. And there aren't a lot of people who can say they single-handedly saved the world, but this is two of them. So Stanislav Petrov was in the Soviet military during the Cold War, and he was in charge of a radar installation. And in 1983, tensions were pretty high between the US and the Soviet Union because the Soviet Union had just shot down a US airplane that was passing over, killing a congressman. And his radar station reported that the US had launched a series of nuclear missiles towards the Soviet Union. And so at that time, neither side really had defensive capabilities, so their only option was to attempt to obliterate the other side before further attacks could be launched. But instead of reporting the launch of US missiles to his superiors, he just said, "There's been a bug in my radar detection system, it's not working." And if he hadn't said that, the Soviet Union probably would have responded, and that would have caused the US to respond, and the resulting nuclear holocaust would probably have killed everyone. Vasily Arkhipov was a similar thing. He was on a nuclear submarine in the Gulf during the Cuban Missile Crisis, and his submarine was very low. It couldn't communicate with the outside world, and the sub's instructions were that if they were attacked, they should launch nuclear missiles at the US. So the US, unbeknownst to the submarine people because they were too deep, used these small explosives as communication devices because radio waves couldn't penetrate that far. But the submarine heard these explosions and thought that war had broken out, which meant that they should launch nuclear missiles at the US. So both the commanding officer of the submarine Arkhipov was on and another officer thought war had broken out and they should launch nuclear missiles, which again would have probably escalated into a global holocaust. But Arkhipov talked down both the commander of the submarine and this other officer and convinced them to surface without firing any missiles. So the point of these stories is just that human existence is not guaranteed, and it's actually kind of surprising that we're still here because our existence relied on a bunch of really contingent and lucky events, like someone like Arkhipov happening to be on a nuclear submarine whenever things went bad. All right, next slide. So today I'm going to talk about what are these existential risks, what are reasons why the world might end, and then use the standard charity evaluation template of examining the importance of the issue, how tractable it is, and how neglected it is. Next slide. So, can you read that? Okay, so this is just a plot of different risks. The horizontal axis is how severe the risk is, and the vertical axis is how many people it affects. So on the bottom left, you have imperceptible personal risks, like losing one hair. As you go over to the right, still impersonal, your car is stolen in a fatal car crash, more and more severe risks. Then as you go up, it affects more and more people, so fatal car crash, genocide, short-lived global tyranny, aging has affected large numbers of people throughout generations, and then potentially there are even worse risks. So today we're going to be talking about where that X is, these risks that affect a huge number of people for a huge amount of time, possibly for the rest of the existence of our universe, and they're also extremely severe. So next slide. Yeah, so most effective charities that people talk about are kind of in this range, that they focus on problems that affect a decent number of people or perhaps the entire world, but generally not multiple generations, thousands of generations, and they're pretty severe. But just kind of one intuition we might have is that if we want to do the most good, we want to be as high and to the right in this graph as possible, and so that's one reason why we might have to compare these potential risks. All right, next slide. Yeah, so what are some specific existential risks? Global warming is one that I think everyone is familiar with, so I won't talk about very much. But there's a possibility that a heating process would lead to a cyclic, sort of self-reinforcing cycle of increased heating that would cause the Earth to be uninhabitable. There are obviously a lot of people working on that. Nuclear security is not a very big issue anymore with the end of the Cold War. The major remaining thing is India and Pakistan are both nuclear powers, and they both lack a lot of security controls that the US and Soviet Union have for their nuclear missiles. So there are some people working on ensuring nuclear security in South Asia. Biosecurity is one of the big ones. I'll talk about that in more detail later, but basically this is preventing either natural pandemics or human-engineered pandemics from killing huge numbers of people. There's really no one working on this outside of the US government, and even there, most of their work is focused on preventing terrorism rather than natural pandemics or accidental pandemics. Machine intelligence is one that I won't get into because I think we could do a whole talk on it, but there's a potential that machine intelligence would cause the extinction of humanity. One broad spectrum solution is disaster shelters. So the Polynesian islands, there are tens of thousands of people were on them by the time Europeans reached them, but they were originally populated by only about 100 people. So that indicates that a very small disaster shelter could house enough people for the Earth to recover from a large number of possible catastrophes. And again, no one's really working on that. And then, of course, there's just meta work to figure out what are the biggest existential risks and what should we do about them. All right, next slide. Okay, so moving to the importance, tractability, neglectedness framework. So this is from Jan Talon. He says, existential risks would take on not just the number of people alive now, but the number of people not yet born. Compared to that, even very serious concerns like malaria, one of the biggest things that rich people seem to be acknowledging, are minuscule. Okay, so next slide. Put some numbers on that. There are 7 billion people currently alive. There are 10 billion projected to be alive on Earth by the end of this century. But if you make some reasonable projections about how long before the sun burns out, could we colonize other planets and some things like that, there's just a huge number of people. That's supposed to be 10 to the 23rd. So there's like absurdly huge number of people who could theoretically be born who won't be born if humanity goes extinct now. So if you contrast that with malaria, 500,000 people die every year from malaria, which is really, really bad, but it's a much smaller fraction than even the number of people currently alive who would die due to an existential event. And it's insanely smaller than the number of people who could theoretically be alive that would not be born because of this existential event. Next. Okay, so if we did go extinct, that would be really bad, but one concern we might have is that, well, we probably won't go extinct anyway, so we shouldn't worry about it. People who have studied this have found surprisingly high results for the likelihood of human extinction. So the UK commissioned a catalog of extinction risks, and that gave humans about a 50% chance of surviving the next century. Nick Bostrom, who's a professor at Oxford, who's a major researcher in this field, estimates a 25% chance of human extinction before 2100. And the Stern Review, which was this huge economic review of largely global warming, gave humans a 10% chance of dying before or going extinct in the next century. So human extinction is not just theoretically possible, it's in fact pretty likely even within our own lifetimes. So all those things are based on very detailed calculations, but one kind of intuition we could have about why we think humans will probably go extinct is what's known as the Fermi paradox. So this says there are a large number of stars like ours. It's not very unique. In fact, our star is actually pretty young. Our sun is pretty young. Around those stars, there seem to be a large number of planets. Presumably, a lot of them are habitable, and it seems like if they're habitable, they should develop life, which will become intelligent, and then be able to travel between the stars. So if there are all these billions and billions and billions of opportunities for interstellar travel to develop, the question is why hasn't it developed? How come there's nobody else out there? And the answer is they all went extinct. In all these billions and billions and billions of circumstances, every single one, they all went extinct before they could develop interstellar travel. So if you go to the next slide, this event is known as the Great Filter. So we start off with a habitable planet, and then there are these various progressions. Life has to evolve. You have to evolve multicellular organisms. Species need to evolve tool use, and then you get to interstellar travel. And at some point in that timeline, every single species has gone extinct. So it could be that this is something humans have already passed. It could be that multicellular life is really hard to develop, and that in all these billions of other circumstances, they just stuck at single-cell life. I think that's possible. But it could also be that in all these other planets, their equivalent of global warming or nuclear weapons or whatever, they didn't survive those things. So just without knowing any information, we should assume that it's pretty unlikely that humans would survive to the interstellar age. And it seems like humans will develop interstellar travel within the next 100 or 200 years if we don't go extinct. So that might give us a reason to think that humans probably wouldn't make it through the next century or two. Next. Okay, so that's the importance aspect. It would kill a large number of people if we went extinct, and it seems like it could very well happen. In terms of neglectedness, I think most people haven't thought about this very much. I didn't think about it very much until recently, but even in academia, it's extremely neglected. So you can see there's about 10 times as much academic research on Star Trek as there is on human extinction, and dung beetles are studied about 100 times more than human extinction. Next. Okay, so with the major problem that comes up when you talk about extinction risks is it's necessarily speculative. You can't do like randomized controlled trials and see like under what circumstances do species go extinct. So one nice thing to look at is asteroids, because we have very good astronomical data and very good historical data that tells us how likely an asteroid is to hit the Earth, and it allows us to do a very relatively precise cost-benefit analysis of extinction prevention. So the probability that an extinction-level asteroid would happen in the next century is about 1 in a million. They come by about once every 800 million years. Dinosaurs went extinct about 70 million years ago. There have been various proposals of systems to deflect these by shooting rockets at them. They range between $1 and $20 billion, but let's say we take the conservative end and say it'll cost $20 billion, and let's be very conservative and say, well, humans will go extinct in a century anyway, so this asteroid prevention system will only give us another century. Even once you do all that, and you multiply it out, it turns out you're spending about $20,000 per year of life saved, which is not amazing, but it's not horrible either. But then once you say, okay, we don't care just about the 10 billion people that will live in the next century, but we care about all the future people, the cost is almost zero. It's 10 to the negative $16 per life that you save. So a tiny, tiny fraction of a penny is what you would expect to spend to save one person's life.
So those are supposed to be superscript.
Yeah.
10 to the 23 people could live possibly, and 10 to the negative 16.
Yeah. So it turns out that asteroids probably aren't the most important thing to deal with, because NASA is kind of already tracking them, and there's not that much more to do. But the next slide, biosecurity seems to be much more promising. So there are natural pandemics which historically have wiped out large fractions of the Earth. The bubonic plague killed about half of Europe, and that was with the very slow travel that existed in the Middle Ages. So it would probably be much more devastating if it occurred now. And there was a flu about 100 years ago that killed 7% of the world. But it seems unlikely that natural pandemics will kill literally everyone. Just historically speaking, it doesn't seem like that's occurred for any species we know of. So the bigger risk is human-engineered threats, and they talk about bio-error versus bio-terror. So it's possible that a terrorist group would develop biological weapons that could kill a lot of people. It actually seems more plausible that that would happen than that a terrorist group would develop nuclear weapons. But again, it's kind of unclear that a terrorist group would be able or have the desire to kill literally everyone. So the more likely scenario is just the accidental release of research pathogens. For example, the University of Wisconsin-Madison got in the news a couple years ago because they purposefully engineered a strain of flu that was much more infectious and deadly than existing flu strains. So if that got released, it would travel very broadly, kill large numbers of people, similar to the 1918 flu, including probably most of us because we're too close for a vaccine to have been developed. So the good thing is that there's a lot that can be done to prevent these. For example, improving and connecting surveillance systems. We saw that with the Ebola outbreak. The US seemed to be really incapable of containing the disease, even though there was a huge amount of effort directed towards it, and Ebola is not a very contagious disease. So if there was some actually contagious disease, like a more infectious flu strain, we would need significantly improved procedures to deal with that. And either lobbying or developing those procedures seems like a very cost-effective thing to do. Another thing is developing new things, new vaccines. For example, right now, every year you have to get a new flu vaccine because the virus mutates annually. But it seems possible to develop broad-spectrum vaccines which would affect you, or which would cover you for your entire lifetime across a wide variety of viral mutations. And so when people have examined the US's ability to respond to global catastrophes, global pandemics, we found that the US is really extremely unprepared, which is very good for tractability because that means it's very cheap to improve. It's a lot cheaper to move from an F rating to a D rating than it is to move from an A to an A+. So that means there's some very basic introduction of security procedures and disease surveillance procedures and things like that that could really dramatically decrease the risk of global pandemic. All right, next. So yeah, to summarize, using that importance, tractability, neglectedness framework, I think it's hard to disagree that existential risks are the biggest impact things that we could possibly hope to prevent by many orders of magnitude, even compared to something like factory farming, which affects more animals than humans. That number is still dwarfed by the number of potential beings that could exist that wouldn't if we all went extinct. Also, in terms of neglectedness, it seems, with the exception of global warming, there just aren't very many people working in this, and so we would expect that a lot of the low-hanging fruit is still available. Tractability is the biggest concern because, like I mentioned, you can't really do controlled experiments or things like that you can with poverty. But it still seems like there are good options, even with things like asteroids. The cost-benefit ratio seems pretty good. So yeah, that's the summary of existential risks.